In this video, we'll start with the next experiment of digital electronics, that is the use of an asynchronous counter. The aim of this experiment is to study the IC7490, which is an asynchronous decade counter. So an asynchronous counter is different from a synchronous counter since it uses two separate clocks. And over here, a decade counter implies that the counter can start counting from 0 and goes up till 9. So the apparatus that we require for this experiment is the baseboard, a single IC, that is IC7490, and a couple of jumper wires. So following the similar procedure, you'll have to mount the IC in any one of the 10-pin sockets, and using the provided circuit diagram, you can make the connections for VCC, ground, and so on. And since it is a decade counter, that is, we'll have 4 output bits, so you'll have to connect 4 output pins to the LED box. And this is the circuit diagram for the IC. As shown over here, we have a clock A and a clock B, and they are not common. That is why we can call it an asynchronous counter. So the clock A will get a clock pulse from the onboard clock, and clock B will get a pulse from the first input bit, or QA, that is pin 12. So pin 12 is also connected to pin 1. Other than this, we have other connections such as the VCC at pin 5, the ground at pin 10, and over here at pin 2, 3, and 6, 7, we have reset and set pins, all of which will be connected to ground. And we have 4 output pins, that is QA, QB, QC, and QD. These denote the BCD output. The BCD output also stands for binary coded decimal. So you can connect these 4 pins ABCD directly to the LED box, and you can see the binary output counting from 0 to 9, or you could also connect them to the 7-segment display using an intermediary IC that is not included with this experiment. Using that, you could also see the numbers going from 0 to 9 on the 7-segment display. So now in the next part of this video, we'll demonstrate how you can implement this circuit on the mobile lab and how you can verify your output using the LED box. In this part, we'll demonstrate the working of an asynchronous mod 10 counter using IC7490.
So we have already implemented the circuit. You can also do the same by referring to the manual. Here I will just show you the output. So here we can see that the output goes from 0 to 9, which means it is mod 10 counter. So let's see the count. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0. So that was the mod 10 asynchronous counter.